So welcome again to another clip. So if you remember, last time we did the first clip, which was question 1. So we answered question 1, A and B. So now we're going to answer question 2. So question 2, we've seen that these questions, they are too long, so we're going to cut them short. So we're starting with question 2A. So question 2A, it was probability. So the probability is, the question reads, two boxes A and B contains balls of the same size. Box A contains 2 green balls and 3 blue balls, while box B contains 4 green balls and 2 blue balls. So if one ball is selected at random from each box, what is the probability that both balls selected are blue of different colors? So now, the main instance is that this question may seem to be very difficult, but I just want you to know that despite having 2 boxes, forget about the type of box, you just know that the numbers, or you say the number of balls and their color which are in the first box are the same ones that are in the next box. So we cannot be disturbed by the statement by saying no, there are 2 boxes, and you know if one ball is selected at random from each box. Okay, quite alright. Yeah, it is part of the question, but just focus on the colors of the balls that are found in both given boxes. So now we are going to add the total of the balls that are in both given box. So I'm going to find that. So they are saying that 2 boxes. So box A, okay, so we say box A contains 2 green balls. So box A contains 2 green balls. So 2 green balls you're going to add with another green balls which are found in box B. So box B contains 4 green balls. So I'm going to say 4 green balls. Alright, so if you add the 2, we are going to have 6 green balls. Okay, so we go to the other type, to add to the other color. So we have also, so they're saying that box A contains 2 green balls and 3 blue balls. So we're going to say we have 3 blue balls. So 3 blue balls we add with the other blue ball which is found in B. So we're going to say B contains 4 green and 2 blue balls. So we're going to 2 blue balls. So when you add, you're going to have 5 blue balls. Quite alright. So that was the main starting point. So now forget about the statement, so long as you've understood what I've just said. Listen. So we're going to solve question A1, Roman numeral 1. So we're going to do this with the help of the tree diagram. So how do we come up with the tree diagram? So you can introduce the tree diagram. I'll just use here, we're going to say probability tree diagram. I'll just draw a short one. So the tree diagram, so the main colors that we have here, we have 2 colors. So meaning we have green and blue. So I'm going to use the first one. The first one as green, and the other one as the blue. Sorry, I have to put it here. So we're going to say, what is the total number of both colors if we add the total number of the 2 colors? So the total number of the 2 colors, we have 6 plus 5, which is 11. So we have 11. So meaning we're going to say the green one to be represented with the fraction of 6 out of 11. Now we're going to the blue one. So the blues will be represented by 5 with a fraction of 5 over 11. So now we know that they have to differentiate with a 1. So we're going to say, like we're going to do this. So I know that so this green, we're going to put another green there. Then here it will be blue. Even here we're going to do like this. So here we're going to put blue, then here we're going to have green. So I'm going to say it will differentiate with with 1. With difference of 1. So we're going to say 6 minus 1, 11 minus 1. So we're going to have 5 over 10. Now coming to the next, the only number which is affected in the fraction when it comes to the blue one, it will be the one which is down. The one which is down, that is the one that is going to be affected, but the one on top, it will remain the same. So meaning we're going to have 5 over 10 of the of the blue. So now we come to the next. Even here we're going to differentiate. We're going to say 5 minus 1, 11 minus 1. We're going to have 4 over 10. When it comes to green, the only number that can be affected, it is the one which is what? Which is down, not the one which is on top. So meaning we're going to say we have 6 over what? 10. Have you seen? You know that the probability of being given two different quantities, it's supposed to giving us what? 1. So if you add the blue plus the green, here you're supposed to get what? 1. Even here when you add the blue plus the green, you're supposed to get what? 1. That's how it is. That is the probability. Even here at the starting point, if you add the green and the blue, you're supposed to get what? 1. Anything that exceeds 1, which means that your solutions is wrong somehow. So this is how we're going to do it. So this is the tree diagram, a short tree diagram. Now we haven't been asked here to draw the tree diagram, but suppose if you've been asked to draw the tree diagram, it's supposed to look like that. I know some teachers, they have that character of twisting the questions. They may twist it and give you the question saying with the help of the tree diagram. So now that is the tree diagram. Let us go to the first question. So the first question, it said, what is the probability that both balls selected Awati are blue? Okay, so both balls selected Awati are blue. So the probability of those balls that were selected are blue, we're going to have, so blue. Okay, so I have blue here. So meaning we're going to use this law. They've said that they are blue. So meaning we're going to use the same law where they have laid the blue balls. So we're going to say the probability of both they are blue is equals to, we're going to say we have 5 over 11 multiply with we're going to have 4 over 10. You multiply this. So meaning we're going to have you say 5 here, 1, 5 here, 2, meaning this times that you have 4 over 11 times 2, we have what? 11 times 2, which is 22. You can reduce this by saying any numbers can go from into 4 and 22, it is 2. So 2 here, 2. 2 into 22, 11. So meaning we have 2 over what? 11. That is the answer for question 2A Roman numeral 1. Then we go to 2A Roman numeral 2. So it is direct. So that question, which is question 2A Roman numeral 2, it says that what is the probability that both balls selected are of different colors? So are of different what colors? So we're going to see the laws which contains the different color of what? Of balls. So we have, if you see the first law, it contains the probability of the same color, which is what? Green. This one, it contains the probability of the same color, which is what? Blue. Okay? So we're going to see if you get this one, okay, quite alright, this one contains different, we have green and what? Blue. Okay, this one, it contains different, we have blue and what? And the green. So meaning we're going to get the 2. The number 1, it is this one, the number 2, it is that one. So we're going to say the probability of getting the different one. So the first one, it will be green and what? Blue. Okay, and the other one, it will be blue and what? And green. Okay, so meaning it is equals to the probability of getting these different colors, we're going to say is equals to green multiplied with B plus blue multiplied with what? Green. That's how it is. So I'm going to substitute. So I say green multiplied by blue. So green multiplied by what? Blue. So meaning we have 6 over 11 multiplying with 5 over what? 10 plus blue multiplying by green. So meaning we have 5 over 11 multiplying with 6 over what? Over 10. Okay, so meaning we are going to say, we can do this by saying, we can reduce this. So we can say, here 5 into 5, 1, 5 here, 2. 2 here, it's 1, 2 here, it's what? 3. Okay, that's 1 more. Then we have 5 here, 1, 5 here, 2, 2 here, 1, 2 there, 3. Okay, so meaning we have 3. Okay, so we have 3 multiplied by 1 to be 3. 11 multiplied by 1, 11 plus. Here we have that times that, it will be 3. Then you do that, you have what? 11. Meaning the common denominator here, it is what? It is 11. So 11 into 11, 1 multiplied by 2, 2 plus 11, 1, 1 multiplied by that. So meaning we have this plus that, it is 6 over what? 11. Therefore, the probability of different colors is equals to G B G is equals to 6 over 11. See you in the next clip.